So I keep forgetting to switch. Next section, don't worry, we'll do more of those proofs to practice, but it's titled Proving Geometric Relationships. You're not going to have to do any of the proofs like we did yesterday, but when you're saying that you're trying to prove something, it just means you need to give a reason. So sometimes you can just say this is true because and give a reason, and like that's all you need to do. But so we're going to start to identify different theorems. So theorem 2.1 and 2.2 were just the properties that we talked about before, so I didn't write them down as like theorems, but this one is called the right angle congruence theorem, and it's really simple. It says all right angles are congruent. Remember, a right angle is 90 degrees. So that one is a pretty straightforward one, but theorem. So I'll go into a little bit more later, but so if you needed to show that, like to say that two angles are congruent, just knowing that they are right angles is not good enough. You would need to actually say it. Well, this angle and this angle are congruent. And what's your reason? Well, all right angles are congruent. Okay, you can't just say, well, they're right angles, so they're congruent. Like, you're right, you just have to actually have to say it. So, all right, theorem 2.4 is called the congruent supplement theorem. And again, I will never ask you what's theorem 2.4. I probably won't ask you what's the title of it. You just need to know the information. So it says if two angles are supplementary to the same angle, or to congruent angles, then the angles are congruent. Okay, so let's dive into that a little bit more. So if we had that this angle was 80 degrees, and I'm just going to call this angle 1. And then over here I had a separate picture, and I knew that this one was 80 degrees. And like I was told that those were supplementary, then I could say that angle 1 is congruent to angle 2. Because they are supplementary to congruent angles. Okay, the other shape to using the, all right angles are congruent, or if it says this angle is supplementary and these angles are supplementary, well, I can say these two are congruent because of the congruent supplement. Okay, or I can say that can, or figure that can happen is so if it said angle 1 and angle 2 are supplementary, and it says angle 2 and angle 3 are supplementary, then based on that theorem, you could say angle 1 is congruent to angle 3. Because they are both supplementary to the same angle. There's an easier way with that picture that we'll talk about to say that 1 and 3 are congruent. in just a minute, but that's one of the like pictures that we can deal with. Okay, theorem 2.5 is pretty much the same theorem as the one before, but with complementary. Oh, it says congruent, complementary, sorry. Congruent. So it's the same wording. If two angles are complementary to the same angle or congruent angles, then the angles are congruent. So same idea. If you know two angles are complementary and two different angles are complementary to the same angle, then those angles are congruent. So same idea as the last one. Excuse me. So we have a postulate 2.8. So all the postulate 2.1 through 7 were those diagrams that we did last week, the point line postulate and all those things. And this one is linear pair. We've talked about this one already. If two angles form a linear pair, then the angles are supplementary. So it's kind of weird that they put it in this section because they wanted us to use it in yesterday's section. So if you knew that two angles were a linear pair, then the conclusion that you can make is, hey, those angles are supplementary, and the reason you would just say, linear pair. So you can kind of use the title of a postulate if you happen to remember it. And then you could say that the angles add up to 180 if you needed to, because supplementary angles add up to 180. That's the definition of supplementary angles. You're going to go back. They're complementary to the same angle, or you're going to use the different theorem. Okay, so here's another theorem, last one for today, but this one is probably one of the most used theorems in the whole book. Vertical angles, the vertical angle congruence theorem. And I've told it to you before, but vertical angles are congruent. It's very useful in a lot of different contexts. So if I had these four angles, angle 1 is congruent to angle, angle 3. And angle 2 is, I'm moving too fast, congruent to angle 4. That one comes up a ton, and it's used to, like all theorems have to be proven true before you can actually say that they are a theorem. So, but you can use like previous theorems and postulates to prove that that's true. So if I was going to, and I'm just going to very loosely like write this out, but using this like picture, I could say that angle 1 and angle 2 are a linear pair. Therefore, angle 1 and angle 2 are supplementary because of the linear pair postulate. I could say that angle 2 and angle 3 are a linear pair. Therefore, angle 2 and angle 3 are supplementary. Definition of a linear pair. So then what I've just done is I've kind of created that angle 1 and 2 are supplementary. Angle 2 and 3 are supplementary. Therefore, angle 1 is congruent to angle 3 because of the what's called congruent supplement theorem that we just talked about earlier. So, I mean, I could write that up in a more formal like manner, but there's proving angle 1 and angle 3 are congruent without saying vertical angles. So, since that's been done somewhere else, you know, before any of us, we know that just vertical angles are congruent. Okay, so today's assignment is just like you'll have some like vertical angle like stuff. So let's look at that. No, they're vertical angles. You're going to use So you'll have some problems toward the end of the assignment that look like this, and it'll just say find the value of x and y. So I look at, you know, the 2x plus 4 and the x plus 10 are vertical angles, so they're congruent or they're equal. And then we just solve the equation. And then do the same thing for the y part. And the numbers probably, like if you plugged them back in, don't make sense because those angles should be, you know, the 2x plus 4 and the 3y minus 2 should form a linear pair, so they should add up to 180. But if you plugged in x equals 6 and y equals 8 into those numbers, it won't happen. So it's just there to illustrate that you're going to look at that one and that one as equal for vertical angles, and that one as well. Okay, so you'll have a picture. It's actually a picture of scissors that make a really skinny like X, something like that. And it labels the angles. And so it tells you, you know, if measure angle 1 is this, what are the rest of them? And so you can do vertical angles for 1 and 3, so they'll be the same. And then you can do Angle 1 and 2 are linear pairs, so they're supplementary. They add up to 180. So if like angle 1 was 100, then angle 2 is 80. And then you could do vertical angles for the other two. Okay. All right. The first 3 or 4 problems, it's just a bunch of pictures, and it says identify the pairs of congruent angles in the figure. Explain how you know they are congruent. So if two angles were right angles, you could say this angle is congruent to this angle, and how do you know? All right angles are congruent. Okay, so when it says the different theorems as your explanation, okay, and there could be more than like one pair of angles that are congruent in the picture. So if you find one pair that are congruent, there could be other pairs in the same picture that are congruent using maybe a different reason. Okay, so no proofs today, but you kind of have to, in some cases, you have to provide a reason why you're saying two angles are congruent. Okay, so hopefully today, because you don't have to do any proof stuff, should be a little bit easier, but tomorrow we're going to get back into doing some proofs. So just using some angles instead of segments. All right, so have a great day. Ask questions tomorrow on stuff that you don't understand. See you later.